And now we are officially live as part of the Humans to Mars Summit. I sort of quickly mute everyone. As part of the Humans to Mars Summit, I've had the wonderful opportunity to get to interview some of the people that are working quite closely with the people that are organizing the event. And of course, Ellen Stofan, Dr. Ellen Stofan is by no means a stranger. We have worked with her on several occasions. She was the former chief scientist at NASA, and I will ask you what that means. And now she is the head of the Smithsonian Institute Air and Space Museum in Washington, D.C. Is that correct?
That's correct.
All right, so let's go back. What is the chief scientist of NASA? What does it actually mean?
So as chief scientist of NASA, I got to look at all the science that we do at NASA, from studying this planet to studying the planets of and moons of our solar system, to studying our sun, to studying the universe, as well as all the science that's done every day up on the International Space Station. Put all those together, think about what are we doing, why are we doing it, how are we doing it, and advise the NASA administrator on what are the science priorities, how do we best use science going forward. So I got to work on fun things like, what are we going to do with the ISS in 5 years? And are we really going to be able to turn it over to commercial space companies? And that whole idea of getting humans to the moon, and then onto Mars, how exactly do we do that? So lots of fun things that I got to work on.
Wow. Do you miss it now that you're not there?
You know, what I really miss are the people that I worked with. I worked with a true hero, Charlie Bolden, who flew on the shuttle a number of times. Just an amazing individual. And I really, really miss the people that I work with.
Okay, but at least you're still connected to NASA at the moment, and you're doing a lot of work with them.
Yes, very much so. And now I feel like I'm doing really something important, which is how do we tell that story of the exploration of how we got off the ground and defying gravity, from getting into the air with the Wright brothers in 1903 all the way to the Sea of Tranquility in 1968, to where are we going next? Sending humans to the moon, sending humans to Mars, you know, moving outward. It's this amazing story to me of exploration, of adventure, of ingenuity. And we tell that story here at the Air and Space Museum.
Do you think that the way the museum has been currently, maybe even now, the way you've been telling the story could be changed? I think because maybe a new audience, maybe a new generation of children, they tend to see things in a different way.
I think we absolutely have to change it. You know, when this museum opened here in 1976, it was just a few years post-Apollo. Everybody had just lived through Apollo. And in fact, you know, a lot of people at that point, very few people actually flew on airplanes. Here now, fast forward 43 years later, it's a different world, right? I mean, now we have people living in space for 18 years up on the International Space Station. And most of the kids today, most of the population of the world was born after Apollo. And they're not even quite sure it happened sometimes. So I think how we tell the story has to change. And also, I think most of your audience today would agree they're a much more digitally oriented generation. That's how they're used to getting information. They tend to be on the internet. So how do we, for kids who can never come visit us at the Air and Space Museum, how do we reach out to all of you? What's the best way to get you information about what we do here? And those are the kind of questions we're asking as we actually physically rebuild, but also kind of mentally rebuild our building here on the National Mall in Washington, D.C.
I mean, I think at the moment you are in a very enviable position, because you're coming to redesign something that's been around for a long time. And now all of a sudden you're getting an opportunity to think it through and say, hold on, can we deliver this in a better way? And now you get a chance to, hopefully with the funding, revamp the center for the next 2 decades or 3 decades.
Yeah, I'm really coming in at the perfect time, because unfortunately our building here on the National Mall is actually falling apart. The stone on the outside is warped and it's cracked. And so we actually have to basically rebuild the building. But what an opportunity to say, well, while we're doing that, if we have to take all the artifacts out, what do we put back in? What are the stories that we need to tell that we haven't been telling? How do we inspire that girl who could be someone who's listening out there today, who's going to be the first girl to walk on Mars? How do we get her excited and inspired? And so it's a huge opportunity that we have here.
Unbelievable. So I know that we've got students who would love to ask questions, and we have some friends in Russia who are also joining us as well. Hello. So we've had India, we've got Russia, we've got the US, and I know we've got people who are watching it live at home via the live stream as well. So Alison, is there anyone in your class that would like to kick off with some questions? Because I've got lots of questions, and if they're too shy, I'm going to take advantage.
Oh, no, we have one right here.
Good.
She'll introduce herself.
Hi, I'm Sneha. I have been to your museum, and today I'm going to ask you a question. My question is, what changes are coming to the National Air and Space Museum under your leadership?
That's a great question, Sneha. Thank you. I'm so glad you've had the opportunity to visit, because it really is an amazing place. So, you know, one of the things that we like to talk about is that we're a museum of ideas that defy. You know, before the Wright brothers flew, people used to say, well, you might as well fly, because flying was something that people regarded as impossible. And of course, the Wright brothers flying, which we have the original 1903 Wright Flyer that the Wright brothers flew at Kitty Hawk here in the museum, that'll still be here after we are transformed. That sort of standard of impossibility actually, you know, the next one was, well, you might as well go to the moon. Well, that one lasted right till about 1968, till we went to the moon. And right now, I'd say the next standard is, well, you might as well walk on Mars. And, you know, that's something actually we don't talk about here in the museum right now, is what's next. So when you come back to the museum for your next visit, I think what you're going to see a lot more of than what you remember is a lot more looking forward. Where are we going in aviation? How are airplanes going to change? How is the way we use airplanes? Are we going to have flying cars? How are we using drones and increasing in different ways? So I think there's lots and lots of exciting things looking forward. And again, how are we going to get humans to Mars? And what's going on with companies like SpaceX and Blue Origin and Virgin Galactic? Those are the stories that we weren't telling that we're going to be able to tell now. And in fact, just about 3 weeks ago, we got a new engine into our collection that actually was on the first Virgin Galactic flight into space that took place in December. So we're already starting to collect new artifacts that will help us tell these new stories.
That was a super question. I think my job is going to be taken over. Lovely stuff there. Well done. Well done. Hold on. I think you were just muted there, Alison. On that note, another big event happened recently with Virgin Galactic. I know that Beth Moses and the team, they flew recently, and now it's astronaut 570, 571, and 572. How is that going to change space as we know it with commercial space travel?
You know, this is such an exciting time period because obviously, Steve, when you and I were growing up, hardly anybody got to go to space, right? In general, the astronauts came from a military background. They were mostly from the United States, and they were certainly all male. So what has changed over the last, say, 40 years since then is you've seen astronauts coming from lots of different countries. We've seen women astronauts. We've seen people of color be astronauts. So that world has changed. But one thing that's been constant over the last 50 years is they've all been government astronauts. So whether they're from Russia or Japan or Europe or the United States, it's always been the government that funds the space program. With Virgin Galactic, we've got something new going on, which is also true coming up for Blue Origin, and that is private companies sending people to space. This is space tourism. This is something that, as a science fiction reader, I've been reading like this was going to happen, and it was some far-off science fiction-y thing, and we're on the verge of actually seeing it happen, and Virgin Galactic has really been, you know, pioneering this, and with getting their more crew members up last week, they're moving towards getting those first real tourists up into space. Now, the Russian space program has taken some tourists up to the International Space Station, so this has happened a little bit before. But what we're talking now is a whole different scale. The thing that's hard right now is I think for the next 10 or so years, it's going to cost a lot of money. So it's going to be out of reach of most of us. But as this happens, you're going to see the price come down and down and down until at some point it might be affordable for any of us to go to space, just like right now it's pretty affordable for many of us to fly somewhere on an airplane.
Wow. I mean, I know about the excitement of the prospect of commercial space travel just being within our reach. At the moment, if you had to look at previous astronauts, they were probably spending about $20 to $30 million to fly to the International Space Station via the Russians. But right now in Virgin Galactic, you can do that for $250,000. So you can imagine if it's been scaled down from 20 million down to 250,000, give it a couple of years, it might only cost $2,000 or maybe not 200, but even 5,000 or maybe 2,000 or even $1,000 just to take a quick 30-minute trip to space, spend 5 minutes floating around and come back again.
Yeah, and I think the thing that was most exciting to me, from last Friday's flight that Virgin Galactic did, which again was another test flight, was the look on the photo they showed of Beth Moses's face, the woman who's the astronaut trainer for Virgin Galactic who went up. The look on her face was this combination of awe and surprise and happiness as she looked out the window and got this view of our beautiful, beautiful planet that, again, only 571 other people have been able to get what the astronauts call the overview effect. It's seeing our planet without national boundaries, one planet, this beautiful blue ball hanging in the blackness of space. And the look on her face to me really captured that wonder that hopefully someday more of us will be able to get.
Awesome. I have put in a request to interview Beth because I'd love to hear from her perspective. But I see that Mr. Crouch, maybe you've got someone in your class that would be itching to ask a question? Or are they too shy?
Yeah. Wyatt, you got one?
My question is about how many satellites have you sent into space?
So his question is about satellites into space, yep.
Oh my gosh, we have sent NASA alone, and that's not including the European Space Agency, the Japanese Space Agency. There's the United Arab Emirates has a space agency. Nigeria has a space agency. There have been literally thousands of satellites sent up into space. Right now, NASA has 18 different satellites that are just looking at the Earth. Right now, we've got about 3 satellites at Mars. We have a satellite called New Horizons that just went past an object way out in an area past all the planets called the Kuiper Belt. We have 2 spacecraft, Voyager 1 and Voyager 2, that were launched when I was in high school by a rocket my dad was actually in charge of. And Voyager 1 and Voyager 2 have now left the solar system. So it's really amazing to think of all these little eyes, ears, and that we've spread, looking out into the universe, looking at the sun, looking at all the planets of our solar system, and then really, really importantly, looking back at this planet to understand what's happening on this planet, understanding the effects of climate change on this planet, being able to help us make better models to understand what's going to happen with climate change. So all these thousands of satellites are doing important things. And then I'm not even including things like communication satellites and global positioning satellites that help us, all of you, like most of you guys might have a phone, right? I'm thinking maybe you're allowed to have a phone, maybe you're not. How many of you guys, raise your hand if you have a cell phone? Okay, about half of you. And how many of you have ever used the map on your cell phone to figure out where you were? Okay, a bunch of you. And how many of you have ever used a camera on your cell phone to take a picture? Okay, the camera on your cell phone, that technology came from satellites, cameras being developed for satellites. And every time you ask your phone to tell you where you are, it's using satellites in space to actually figure it out. So you may not think that the space program has anything to do with you, but just your phone actually really relies on the space program for everything it does.
Wow. Well, I mean, if we think about it logically, if you have too many satellites, doesn't that lead to space junk?
It certainly does. And that's something that actually all the nations of the world, and there are over 16 of them now that have space programs, everybody's getting increasingly worried about the possibility that satellites could start running into each other. And there have actually been instances where people have launched satellites into the path of someone else's satellite, and that satellite has had to maneuver out of the way of another satellite. So even though space is really big and it's not a crisis yet, it could get to that point. And so you have a lot of talking going on through the United Nations, through different forums of people saying, how can we make sure that we keep space usable? Because once things start crashing into space and there's a lot of debris or a lot of particles, that actually hurts everybody, because you could actually have so much junk up there that everybody's satellites are getting knocked into and nobody's satellites work. So it's in everybody's best interest to avoid space becoming too crowded and too much of a mess.
Maybe we've got a question from Russia. Are you too shy? You want to ask a question? You can just unmute yourself. There we go.
1 second. Hello, nice to meet you.
Доброе утро.
Доброе утро. Can you hear me?
Yes.
Yeah, you can. Well, I have visited your museum. I mean, I was in Washington and I could see spacecraft. I could see the shuttles, and it was impressive for me. And I would like to know, what is better for visitors to see, to visit? Your museum in Washington, I mean Space Museum, or to visit a NASA museum in Florida?
Oh, that's such a hard question, because the Kennedy Space Center is one of my favorite places on the whole planet. I first went down for a launch when I was 4 years old, and that was when I got my first tour of the Kennedy Space Center. And it is a special place. So I'm going to say and rather than or, because if anybody has a chance, if you're, you know, the Kennedy Space Center is not that far from Disney World. So if you have the opportunity to go to Florida and go to Disney World, don't forget to go to the Kennedy Space Center, because it's really a place where history was made. You know, all the Apollos took off from Kennedy. Pretty soon, the U.S. is going to start launching crew up to the space station with the Boeing Corporation and SpaceX from Kennedy Space Center. So it's a fun place to go. And if you happen to be there when you can see a launch, it's really an amazing thing. But I would argue also, people have to come, as you did, and thank you for having visited, come to the National Air and Space Museum, because we have things that don't exist anywhere else in the world, like the Wright Flyer, the original plane that the Wright brothers flew at Kitty Hawk. We have the Apollo 11 command module, Columbia. We have the original Spirit of St. Louis that Charles Lindbergh flew across the Atlantic. We have a plane that Amelia Earhart flew, though we have a lot of visitors that say, is that the one she disappeared in? And you have to say, stop and think about that. No, it's not. It's her plane she flew before she disappeared in a different plane. We have we have moon rocks that people can touch. So we have an amazing experience too. So you absolutely have to go both places if you can.
Awesome. Awesome. Now, do you have any questions from India? From Hari Krishna, you want to ask a question? Just unmute yourself.
Okay, my question is, it's my privilege to ask one question actually, and this question has been a really problematic for me, and I need immediate answer for this question. And as you know, that NASA has been doing an extremely important role in finding the life on the Mars actually. So in what way the NASA has been successful so far in identifying the living conditions for the human being on the surface of the Mars? How far the NASA has been successful in identifying the living conditions for the human beings to live in the future? That's my question.
All right. So Ellen, I don't know if you got that, but I mean, essentially, you know, we're obviously talking about getting to Mars. How successful are we in terms of living conditions on Mars and getting close to living conditions on Mars?
Yeah, obviously, you know, Mars is a pretty inhospitable place. So a lot of times when people ask me, are we going to have giant settlements of thousands of people on Mars in 30 years? I tend to lean no on that for the very thing that I think it's at the heart of your question. Mars has a couple of things that make it really difficult. One is, first of all, it's really far away, right? It takes 7 to 8 months to get there. On the way there, you're subjected to a lot of radiation coming from the sun, but also coming from something called galactic cosmic rays that are very high energy particles that can actually do damage to human cells, human DNA. So you get radiation on the way there, and then because Mars doesn't have a magnetic field, humans would actually experience a fair amount of radiation on the surface. And actually, the Mars Curiosity rover has sensors on it that have actually been measuring the radiation environment on the surface of Mars for the very reason of understanding what would be the effect of humans living on Mars. So we know if humans are on Mars for very long, they're probably going to have to live underground and probably 1 to 2 meters underground to get away from those really high energy galactic cosmic rays that are so damaging. Again, not a problem here on Earth because of the Earth's magnetic field, but a problem at Mars. The other problem is we know there are a lot of pretty toxic chemicals that occur naturally. No one put them there, that occur naturally in the soil of Mars. Chemicals called, for example, perchlorates, which here on Earth is like a byproduct of the manufacture of rocket fuel. So nasty kind of chemicals. And the thing is, when you go outside on Mars and just think, oh, my spacesuit's going to get all dusty, and then I'm going to go inside, and what if I start breathing that dust? So this is something else that we've been doing experiments on the surface of Mars are, what are the properties of the Martian dust? What's its chemical makeup? And how can we understand it? So, for example, could we design spacesuits that would actually repel Martian dust to make sure that it wouldn't get onto the spacesuits and then potentially be breathed later by humans? So we're doing all kinds of science experiments, getting at that very question you answered. How can we understand Mars well enough so that the scientists and engineers and doctors and explorers that we send to Mars in 20 years can be safe? But right now, I think that all those things I just talked about, that's going to make it hard for us to send lots and lots of people to Mars because it's a pretty harsh environment. And yes, we're going to have to learn how to grow food on Mars in that low gravity environment. We're going to have to find ways to use Mars to manufacture things like Mars bricks to make settlements out of. So lots of work to do. But I'm a little dubious of getting large numbers of people to Mars.
Sure. But now there was an interesting development in the last week. Elon Musk launched an Israeli moon lander that is going to travel to the moon and land there approximately in April. How's that? I mean, we've already had the Chinese arrive and sending some amazing footage. What's going to happen now with the moon? Why is the moon such a big focus?
You know, the moon is such a big focus, especially for the commercial industry, private industry, but also governments around the world, because it's a lot easier than Mars. You know, it's 3 to 4 days away. And so you start saying, well, why don't we use the moon as a testing ground? We went there back in the 1960s, haven't been back except for some scientific spacecraft. Let's go back. And so you see great missions like the Indian mission, Chandrayaan, that helped us learn a lot more about the moon. There's potential resources on the moon, and maybe there's opportunities for space tourism. Think about a moon hotel that you could go visit someday. So I think it's a really interesting question as we go forward, especially over the next 10 years. What is the role of the moon in getting humans to Mars, which is certainly my goal? What is the role of the private sector? How much are our private companies really willing to pay of their own to go to the moon, try to use it for tourism or industry or whatever? I think it's an open question. Is there a profit for companies now, 10 years from now, 50 years from now? When is that tipping point going to occur? And this is all changing right in front of our eyes. Really interesting time.
I mean, in the last 5 years, more has happened. Then, of course, we have New Horizons, not only popping on past Pluto, but now by the Kuiper Belt and looking at Ultima Thule. or Thule, whatever, however you pronounce it. I mean, that's quite a fascinating development.
It's so exciting. I mean, New Horizons, you know, it took it about 9.5 years to get to Pluto. And we absolutely loved those images of Pluto. Didn't look anything like we thought it. I thought Pluto would look like our moon, you know, kind of just craters, nothing very geologically interesting. But I'm a geologist, and I tell you, Pluto was just incredibly exciting to see. And then now we've seen our second, you know, Kuiper Belt feature. Pluto is part of the Kuiper Belt, as are its moons, Charon and what's the other one? I forget Pluto's other
Whichever one you think it is.
Right, that other one.
Yes.
And then out to this latest body, which is so bizarre looking, clearly what we call a contact binary, two bodies that actually at some point collided and stuck together. But the weird thing is they're both kind of pancakey flat, really weird. And things like this, you know, for scientists, it's all very well to predict something and then see exactly what you predicted. But for a scientist, it's way more fun to predict something and then have it be a twist or something not quite what you expected, because that's where you really learn. That's where you say, wow, we don't understand everything. We have a lot more to figure out.
Mm-hmm. Well, maybe, Alison, I see that some of your students are holding up a laptop with Pluto. Ironically, there was an image of Pluto, the Disney character, hidden in the actual planet of Pluto. I don't know if you've seen that. A patch that resembles Pluto, which I thought was quite interesting. But Alison, does anyone in your class have another question? We'll throw another question opportunity to you guys. Yep. Okay, you just have to unmute.
Okay,
there we go.
Introduce yourself.
Hello, my name is Alex, and I'm going to ask you a question about what could we learn about climate change on Earth from your research about Venus?
Wow.
Alex, that's such a great question. And, you know, Venus should only be about 10 degrees centigrade hotter than the Earth because it's closer to the sun. But it's over 500 degrees centigrade on the surface of Venus. Lead actually melts on Venus because it is so incredibly hot. And it's because Venus has what's called a runaway greenhouse atmosphere. And it has so much CO2 in the atmosphere that we actually think early in its history, Venus had oceans on its surface, that as more and more CO2, carbon dioxide, came out of the interior of Venus, it just ran away in the ocean. It got so hot that the oceans boiled off. So Venus has kind of, to me, always been first of all, climate change is real. We understand the role of greenhouse gases like carbon dioxide. And don't think that bad things can't happen in an atmosphere when processes start to run away. So one of the things that's really helped us, you know, I talk to a lot of people who say to me, well, climate change isn't real. We don't really understand the role of greenhouse gases. And I said, well, you know, actually, that's where you're wrong, because we can look at Venus that has a lot of CO2. We can look at Mars, which has a moderate amount of carbon dioxide in its atmosphere. We can look at Saturn's moon Titan, which has a nitrogen-based atmosphere like ours, but in Titan's case, the greenhouse gas is a gas called methane, which is a very powerful greenhouse gas. And understanding the composition of those atmospheres, we can make fairly accurate predictions about the surface temperature. So if there's one thing that we actually understand, it's the role of greenhouse gases in atmospheres. And that's why you see the scientific community so confident that we understand what's happening with climate change, with the role of carbon dioxide, is because we can compare the Earth to other planets.
Sure. Now, I know Amy has just joined us, part of the homeschool fraternity. Amy, do you have any questions you want to ask?
Thank you so much. Can you hear me?
We can.
Yeah.
Oh, wonderful. We just joined, so we didn't really hear the beginning of the conversation, but my daughter has a space question that she wanted to ask. And the question was just about, why does Saturn have rings and what's the purpose of them?
You know, I always tell people that kids ask, you know, people think, well, kids ask questions that aren't very complex, and kids ask the best questions. And they ask the really basic questions that are the questions that the scientific community still really struggles with. And Saturn's rings are one of the great things that the scientific community is still trying to understand. The complexity of Saturn's rings, how they look. And one of the things we absolutely just learned from the Cassini mission is that Saturn's rings are actually going away. So planets have rings because at some point there were collisions of material around them. So say multiple moons, they run into each other, they produce debris, or debris gets ejected or collected by gravity and it goes into orbit around the planet. So think of Saturn's rings as almost being lots and lots of little satellites in orbit around the planet. So they're slowly being pulled into the planet by Saturn's great gravity. And some of the material that's lighter on the very outside of the rings actually at times can escape away from Saturn's gravity. But so you can see right there, that's not a stable situation, right? And so we always knew that. We knew that rings never last. And in fact, there's actually a theory that the Earth at one point had a ring, probably at the time of the formation of the moon. The moon formed when something collided into the Earth, knocked a big chunk of the Earth off along with a lot of other stuff, and that stuff condensed into the moon. But before the moon actually condensed into a single body, the Earth would have had a ring also. So what we just found out from Cassini is that the rate of how fast Saturn is sucking in the rings is actually greater than we thought. And so I can't remember the amount of time, Steve, you might remember, but Saturn's rings are actually going away. But don't worry, not in our lifetime. Saturn will always have
a few billion years before we get to lose it eventually.
Exactly. So we don't need to mourn Saturn's rings quite yet.
Okay, I see Mr. McNulty, your group have finally joined us. Do they want to ask any space questions now that you are there?
Yes, come on up. Come on up. We got some questions for you guys.
Awesome.
This is Holland Middle School. We're in Pennsylvania, and here's our question. Go ahead. Microphone's right here. There's your camera.
Okay. Why won't NASA send another rover to Mars to revive the Opportunity rover, and the robots can become friends?
I love it.
That makes me so sad because I about a week or two ago, it was right when we found out that Opportunity was indeed not coming back, and I started talking about it and I almost started crying. I got this little catch in my voice and I said, I can't be crying for a rover. It's like a car, right? You know, you can't be too sad about it. But you know, the Opportunity rover, you know, it was designed to last for kind of 3 to 9 months. And it lasted over 10 years. And so it's one of those things that you say, is it really worth the money to try to wake it up and go clean off its panels and recharge its battery and kind of give it new life, versus sending one that has much newer technology, can go further, can go faster. And so the money you'd want to spend, actually, it's much better spent in newer, faster rovers, because frankly, that technology is now kind of ancient technology. Just think if someone said, I'm going to give you a cell phone from 20 years ago, you'd be going, no, thank you. And so think of Opportunity as kind of like an ancient cell phone. Even though we love it dearly and we're sad and we wish it could have a robot friend, I'd rather send it a spiffy, new, faster moving, because, you know, one of the things when people say, why do you want to send humans to Mars? In Opportunity's first 10 years on Mars, it went about 26 miles. Now, 26 miles is the distance of a marathon. And, you know, there's some people out there that can run 26 miles in 4 hours. I certainly can't. But you think, let's get a new rover that could maybe go 200 miles in 10 years instead of 20 miles.
Okay, well then on that question, which I think is fascinating, InSight obviously is our latest rover. First of all, it's
not a rover, it's a lander.
It's not a rover, it's a lander, but it's doing some very interesting experiments on the planet. And you being a geologist would know that. Maybe you want to talk us through some of the experiments that it's doing.
Yeah. Now, the thing about InSight that you need to understand is, I'm sure most of you in school in various classes about Earth science, you've seen those cutaway images of the Earth showing the Earth's core, the mantle, the outer crust. And you might think, how do we know what the inside of the Earth looks like? And one of the reasons we know so much about the inside of the Earth is because every time there's an earthquake, the Earth wiggles, right? It shakes. And by studying how those waves of energy, how those waves of motion pass through the Earth, that's how we've been able to figure out the interior structure of the Earth. And in fact, really big earthquakes over about a 7.0, which occur a bunch of times a year somewhere on the globe, those things actually send the whole Earth, that big of an earthquake actually makes the whole Earth wiggle like a big bowl of jelly. And so from that, again, we know the interior structure. Now, I told you all that because what InSight has on it are seismometers to measure not earthquakes, right? They're not earthquakes because they're on Mars. So they're
Marsquakes.
Marsquakes. So InSight is going to measure Marsquakes because we want to know how Mars wiggles, because if we can understand how Mars wiggles, we can figure out the interior structure of Mars, and that'll help us understand its history. It'll help us understand the history of water, believe it or not, on the planet, by really having that three-dimensional cut into the interior of Mars. So InSight is a really exciting mission. Even though it beat out my Titan boat mission, it's a great mission.
Wow, wow. We're going to move over to, let's see, Eric, does your class have a question?
We did have a question. Michael had a question. And Tony has a question if we have time. Michael,
yes, bring on two questions. We've got time.
Oh, hurry. All right, Tony, go ahead and ask yours while you're here.
So, is there any kind of technology that you know of that NASA might want to introduce to the public?
Hold on.
Oh, come closer, come closer.
I didn't hear that. You're going to have to come a little bit closer.
Is there any technology that you know of that, NASA might want to introduce to the public that the public doesn't use yet?
You know, that's a great question. And I have to tell you that almost every day NASA is introducing new technologies to the public that the public doesn't know about yet. For example, there's a water purification system on the International Space Station that that technology is now being taken into disaster areas as a portable water system to clean water when there's been some kind of disaster and people don't have clean drinking water. A nutritional supplement, so basically a vitamin supplement that astronauts take up on the International Space Station, is in over 90% of baby formula that babies drink. So every day up on the space station, and in fact in most areas of NASA, they're working on technologies that actually has huge implications here on Earth. I was skiing last week in Colorado, and there's NASA technology in my skis, in my ski boots, and in the clothes I wear out on the ski hills. So NASA technology really is with you absolutely everywhere you go. And that's the great thing about investing in technology. So when NASA says, well, we're going to go to the moon, we're going to go to Mars, it benefits us right here on Earth every day.
That is just incredible because, I've heard Jim Adams, our friend Jim Adams from the former chief deputy technologist, he talks about the spin-offs that have come from NASA, which are obviously sometimes a little bit below the radar and then sometimes far more glaring and obvious, like cell phone technology and stuff like that, which is absolutely amazing. But of course, we're in a situation where we want to go to the moon. We've been sending rovers to Mars. Why have we not been sending many rovers to the moon?
You know, there's been a lot of scientific rovers proposed to go to the moon, especially to the far side of the moon, near the South Pole, where there's some really interesting rocks that would help us get at this question of, did the moon really form from the Earth? And could we understand the chemistry of the moon better, which would help us understand what was the Earth like before it got hit by something that knocked the moon off? It would kind of allow us to see what were the starting conditions on Earth. So people have proposed, but they haven't been selected. And I think now you're going to see those missions happen now that there's a lot more interest in sending people to the moon. It's really interesting why a mission gets picked versus not. Of course, NASA has limited resources, as do all space agencies around the world. And so they have to say, what's the most important thing to do right now? And, you know, Mars has had this big priority because we've really been trying to nail down this question of, is there life beyond Earth? And Mars remains our best candidate to go figure out, did life evolve somewhere else besides Earth, and how does it compare to life here on Earth? And that's why we've stayed so interested in Mars, and to me, why Mars is still the priority.
Now, if I remember correctly, there was the moment just before the end of your term of office at NASA where you made some announcement about life on other planets. Was it? Did you hinted that some sort of discovery or something to that effect, and that caused a lot of buzz? What was that all about?
Yeah, what I said was, which I didn't think was controversial, I still don't think it's controversial, that in the next 10 years, so say the next 8 to 10 years, we're going to find strong indications of life beyond Earth. Now, what does that mean? Strong indications means that we're going to see some gases in an atmosphere that would be possibly consistent with life. It means we're going to find some really intriguing molecules on Mars, or maybe something on Mars that seems like it could be consistent with the presence of life, but there's still going to be some doubt in our mind. It's going to be like, well, that's good evidence. We're getting closer, but we're not all convinced yet. And I said within the next 20 to 25 years, we're going to find conclusive evidence of life beyond Earth, whether it's on the surface of Mars from rocks that an astronaut breaks open, whether it's in the oceans under the ice on Europa, whether it's from the oceans under the ice on Enceladus, we're going to find evidence of life beyond Earth. And, you know, I don't think that's controversial. I think a lot of the scientific community says it's just a matter of getting the spacecraft out there and making the measurements. And that's why my only hedge in time is, are we going to get the spacecraft out there? Because based on what we know about the evolution of life on Earth, Mars should have had life. There's a good chance there should be life under the ice on Europa, and a good chance there should be life under the ice on Enceladus. And then you have places like Titan that has seas not of water, but of basically liquid gasoline. Could there be life there? We don't know, but maybe.
And when you say life, you're not talking humans, you're obviously talking microbes and
microbes. Okay. Yeah, I think we're still probably about 30, maybe 40 years away from really definitively finding that Earth 2.0 around another star, that blue planet, where we can say, yes, based on the fact that we can image this planet, we can see colors change across the surface, like you can see from space when it goes from, you know, spring to summer to fall. You can see those changing colors associated with life here on the surface of this planet. The technology to actually image planets around other stars, we're still about 30 to 40 years out. We know how to do it. It's just a question of getting the technology all together and making it happen. And it's going to be expensive.
Okay. I know we've got Vladimir who joined us. I think Vladimir might be someone different. So Vladimir, if you have a question, you're welcome to ask a question. Just unmute yourself. We'll see if Vladimir is listening. If not, oh, Vovato. Oh, so you obviously know Vladimir. Okay, there we go.
Hello.
Hi there, Vladimir.
My name is Volodya. I'm from Russia. Okay, I have a question for you. Are there any landscape features on Mars?
Are there any landscape features on Mars? That's a good question.
You know, one of the most fascinating things about Mars that we've been able to see almost since we started studying it was that Mars had some kind of long channels on its surface. They were first thought to be, you know, made by Martians, and they were called canali, or they were thought to be canals. But then as we got higher and higher resolution images of the surface, what you see, especially around the equatorial zone of Mars, but extending up into the northern plains, is evidence of water-carved surfaces. So you can see areas where there used to be running water all across the surface of Mars. And we've also seen features on the surface of Mars that look like dust-covered glaciers. So that if I took a picture of a glacier, say up in Alaska or somewhere in Russia, and I showed you some pictures of Mars, you would be hard-pressed to say which one was the Earth and which one was Mars. So there's all kinds of landscape features on Mars that we associate with either frozen water or running water. Now that's important because it all goes back to this life question. And what we've been able to determine by putting all the data together collected by spacecraft from countries all around the world is that Mars was very wet from about 4 billion years ago to about 3.5 billion years ago. And that's the same time period when the Earth was also wet and life evolved. And Mars's conditions were pretty similar. So we probably should have gotten life on Mars also. But then Mars changed, it lost its water, it got cold. So life either went extinct or it went underground, and it probably stayed in microbial form.
Okay. Mr. McNulty, anyone in your class want to ask a question?
Yeah, Lana, go ahead and introduce yourself. Your camera's right there.
Hi, I'm Lana. Do we have the technology to go to an Earth-like planet if Earth ran out of resources?
You know, Lana, that's a great question. And the answer is a big, huge no, I'm afraid. And that's why I always, when I talk about climate change, I say there is no planet B. You know, this, and Carl Sagan said it years ago much better than I could. The Earth is where we make our stand. And part of the reason for that is we basically use the same propulsion system that we used back in the 1960s. And by propulsion system, I mean what we use to make rockets take off. It's a mixture of liquid propellants and chemical propellants that we use, solid and liquid. But it hasn't really changed, again, since the 1960s. So when you see great science fiction movies and they're like, let's go into warp drive and let's go into hyperdrive and move near the speed of light so that we can move the huge distances in space without it taking tens of thousands to even 100,000 years to travel from galaxy to galaxy, which is what it would take with the kind of technology we have now. You've got to invent a whole new propulsion system. So when I talk to classes like yours, I always say, if the teachers could please add that to tonight's homework assignment, just at the bottom of the page, add in invent warp drive. And if one of your students could invent warp drive tonight, then my answer to Lana would be, yes, we're going to do that. But so far, the answer is a big no, unless one of you makes a breakthrough.
That is actually very important, but they are looking at developing new proton drives. How far are they?
You know, there's plasma drives that would get us to Mars in half the time if they work out. But again, even those aren't getting you to the kind of speeds. They might cut getting to Alpha Centauri, our closest star, from like 10,000 years to 7,000 years. Okay, that doesn't do us much good, right? And the problem you see in a lot of science fiction movies is you're like, oh, we'll put people in deep freeze and then wake them up. But I tell you, one of the problems we already have with astronauts in space is that they don't get enough exercise and they don't get enough pounding on their bones. And so when we have astronauts in space, even if they're not asleep, they actually lose huge amounts of muscle mass and bone density unless they're exercising sort of 2 to 3 hours a day. Because it turns out every time you move against gravity, you're exercising. That's great for those of us who don't like to go to the gym. We can just convince ourselves we're exercising all the time by fighting gravity. So the idea that people could really survive very easily without really huge damage to our bodies in space for long periods of time is a tough one.
Sure. All right, Alison, anyone in your class got a question? Oh, we have two. Oh, you're getting a double header here. Let's have a look.
Excellent.
All right, thanks for asking us again. Here we go. Say your names.
Hello, my name is Thea, and my name is Nirmahi. Our question is, what advice would you give to young students interested in one day working in the field of aeronautics, aerospace research?
You know, that is such a great question. Thank you for asking it. And, you know, I have to say, since you're both women that asked me that question, is we need more women in this field. You know, we still only have about 20 to 30% of engineers, of computer scientists working in aerospace are women. And women make huge and amazing contributions every day, but sometimes women don't feel welcome. And sometimes they might get discouraged. Their friends might say, engineering is for boys, or engineering is not for people who look like you, or computer science isn't for people who look like you. But you know what? It absolutely, absolutely is. And we need your talent because people like you have already made incredible contributions. So what I always tell kids is, first of all, find something you're really passionate about. You know, for me, I wanted to study Mars. I wanted to be a planetary scientist. And everybody around me encouraged me, my parents, my teachers. And you know what? I struggled with math. And in fact, a lot of the times I didn't get very good marks in math. And I really had to work hard but I knew I needed to have it. And I've had so many people say to me, well, I didn't become a scientist or an engineer because I wasn't good at math. And I say to them, I wasn't good at math either. But you know what? I had people who encouraged me. I wish I had known people like Steve, who makes math fun and enjoyable and exciting. It's really my aim to say, you know, every aeronautics person who works on airplanes, people who work in space, not all of them were the top in their class. Some of them were from the middle of their class, and some of them were from the bottom of their class. But you know what they had in common is they had a dream of really wanting to do something, so they stuck to it, they stuck with it, they kept working at it, and they got there. So if for any of you who think of that this is interesting, stick with it. Don't let a bad grade turn you off. Don't let a little trouble with math turn you off. Look at living maths and make math fun, and you'll get there.
I mean, the most important thing that you actually said there is, you know, whenever I interview people, I often ask them, what is the origin story? What switched you onto science and technology? So Ellen, what was your light bulb moment when you decided that something in the sciences was going to interest you? Was it an influential person? Was it a moment, an event? What was it that switched you on?
You know, Steve, that's such a hard one for me because I grew up in a really unusual household. My dad was a rocket scientist at NASA. I went to my first launch when I was 4 years old. My mom was a science teacher in elementary school. She was a 5th grade science teacher. This didn't affect my sister. She became an attorney, but science to me was just something that I grew up with. And I was always interested in. But I think for me, the real moment was when I was about 14, I had the opportunity to meet Carl Sagan and hear him talk about why we were going to Mars. And the fact that you could go and study how Mars formed and maybe learn that if life ever evolved there. And I thought, you know what, that's what I want to do. So there was a person in it, but to me, it was also an environment. But the most important thing I had was people who encouraged me. So everyone who's listening today, if you ever feel discouraged, remember Steve and I telling you, you can do this. You can be what you want to be.
Absolutely. I mean, if I think about it now, if you put someone in a context where your father is a rocket scientist, your mother's a science teacher, you get to go and see rocket launches. I mean, it was inevitable that you were going to be moving in this trajectory. I mean, so what you're saying is that maybe if students are interested in space and science and math and engineering, whatever it is, they should kind of gravitate towards circles that encourage them and support them.
Yes, definitely.
That is very good advice. Now, we've only got about 7 minutes left. And maybe, Amy, you've got another question on your side?
Yes. So I've missed some of the beginning, so you might have already addressed this. But I have a question. I'm wondering, and maybe I haven't missed a headline or something, but when will the next people be sent to the moon? And the next question is, how soon do you think people will be sent to Mars?
Very good questions.
You know, those are great questions. And I get asked that question kind of from 2 different perspectives. And I would say, I've been thinking about this a lot this particular year because we're celebrating the 50th anniversary of the Apollo missions. And you know, you had President Kennedy saying we're going to land a human on the moon within the decade. And we did it in 8.5 years. And we started from scratch. I mean, we really had very few of the technologies. We didn't have the infrastructure. Kennedy Space Center didn't exist. Johnson Space Center didn't exist. So we overcame huge challenges in 8.5 years. Now, at that point, NASA's budget was a lot bigger than it is now. But it's always a question to me to say, if we wanted to get humans to Mars, we could do it in the next 5 years easily, because it's so much easier than the step we had to take to get humans to the moon back in the 1960s. Now, then the question is, will we and can we afford to? And I would say, I think you're going to see humans back on the moon within the decade, hopefully within sort of 5 to 7 years. I think we're going to get humans back to the moon, either through a private company or probably more likely through a public-private partnership with maybe private companies working with government space agencies from around the world, not just the United States. And then humans to Mars. I think we could have a Mars orbital mission by the early 2030s, so about 15 years from now. And then humans down to the surface, probably closer to 2040. So maybe about 25 years from now, we'll actually get humans down to the surface of Mars. But it's more, to me, again, a question of will. Are we going to do it? Is there a mandate to do it? Is there a push to do it? And for people who say, well, gosh, is that a lot of money? I'd remind you of our conversation earlier. When you invest in space exploration, you actually are investing in your economy, and there's a zillion spin-offs that help you in ways you haven't even thought of.
Well, I mean, obviously, the good news is that NASA has managed to get a larger budget for this year, so they're quite excited about that. Now, I know Vladimir Vada has got another question he wants to ask you. So he's just going to unmute himself. There we go.
Hello again. Well, could rovers explore caves or canyons or something like that on Mars, or it's impossible mission for them?
That is a very good question.
That's a great question, and scientists have actually been, and engineers at NASA have already been looking at that. Actually, I'm sure just not at NASA, but also the European Space Agency, and I think even the Russian Space Agency has looked at this a little bit. Is to say, if we think that for example, caves or lava tubes would be a place that people would have to maybe spend, if we're going to be on Mars for, say, a year, you'd want to be spending a significant amount of time underground to avoid that radiation. And so we know where there already are a lot of lava tubes on Mars. We know where they are. And so we've actually had groups that have looked at sort of what would a mission that went into one of those lava tubes, especially maybe an early mission, not with humans, that would explore them, map them out, understand how difficult they are to access. What does the entry point look like? You know, how hard would it be to get not just a person wiggling into an entrance, but actually get equipment into a lava tube? And so, no, these are mission concepts that are actually being worked on. The fun thing that NASA does that a lot of people never see is NASA, the European Space Agency, the Japanese Space Agency, all those agencies spend a lot of time looking at missions that might happen 5, 10, 15, 20 years out and doing lots of sort of concept studies. What are the technologies you need? How much would they cost? What kind of instruments would you do? Those studies are going on all the time for planning purposes.
Sure. Well, I mean that is quite fascinating. But now, if you think about it, New Horizons took 9 years to get there and several years of planning, which means if you take, let's say, a 15-year round, let's say 15 years roundabout to plan and execute the project. You were only just at NASA a couple of years ago. So are there missions that were planned 5 or 6 years ago, even before you, that we are going to hear about in the next few years?
Oh, yeah. In fact, there's a really exciting mission to come up, just to name one, called the Europa Clipper mission. So, you know, I talked about there maybe being life under the ice on Europa. And so in the early 2020s, NASA is going to launch a mission called the Europa Clipper. I'm sure it'll get a fancier name at some point, but it's going to go out. It'll go into orbit around Jupiter, but it'll have lots and lots of close passes by Europa. Europa, actually, there's cracks in the ice on Europa, and it erupts some of that subsurface liquid water ocean out into space. So one of the things the Europa Clipper mission will be doing is to look at those erupting plumes to try to figure out, again, this question of could there maybe be life under the ice on Europa? And so that's just one of the really exciting missions coming up, along with really exciting telescope missions that are going to look out into the universe. Lots going on. There's always missions in the queue that are going to be launched in the next couple of years that are going to change the way we look at the universe, change the way we look at this planet. Lots of fun things.
Wow. I mean, you'd have to convince me. You had me at hello. I mean, I'm always excited about space and getting young people involved in the idea that there's a lot more to space than just the couple of missions that we've had. If you just look at the activity that we've had in space 30 years ago, and the activity we've had in space 20 years ago, and then 10, and the last 5 years, there's been an exponential number of activities, and private entities are launching their own satellites, cube satellites, and private companies are launching their own landers on Mars, on the moon. I think that there's still a lot more excitement to come. But on that note, I would like to thank you, Dr. Ellen Stofan, who is one of my favorite scientists because she is so down to earth and so approachable. Thank you for giving us your time and your enthusiasm and your passion and your words of wisdom. If there was one parting shot, what's the one message you would give to young people with regards to pursuing careers in STEM?
You know, those of us who work in science, technology, engineering, math, computing, design, we have the most fun. We get to explore the universe. We get to understand this planet. We get to help this planet. So if you want to have a career that makes you just want to jump out of bed every morning, that's a STEM career. And plus, they also have pretty good salaries.
Ah, so you said two important things, salaries and excitement. Mr. McNulty, you wanted to say something?
Nah, we just want to say thanks. And guys, let's give a round of applause. Appreciate it.
Thank you so much.
Thank you.
You're welcome. You're welcome. And I see that Alice and your group are all assembled on the carpet there. You want to say goodbye?
Yes, we wanted to say thank you too.
Awesome, awesome, awesome. So we're going to end the broadcast over here, but thank you very much to all of you that took part in the live interview as well as the live stream as well. Ellen, you need to smile so we can get a photograph of you looking at your camera. That's it. There we go, because YouTube sometimes chooses its own random photo of you from the actual interview, and it's always the one where your face is half like this and that. So we just like to ensure. So we're going to get a big smile. There we go. Excellent. And thank you for your team. I know Kelly and the team behind the scenes for organizing all of this as well. We really appreciate it.
All right. Bye-bye.
Okay.